Mission critical data, we all have some of that, and in certain industries there's rather a lot of it. And being critical, it needs platinum grade protection. That means minimizing periods of inaccessibility to the data and zero data loss, even if you lose an entire data center. No excuses. Now the answer to this is synchronous replication with automated failover. And that's a relatively common solution for workloads using block storage, such as databases and other transactional workloads. But what's less common is having this capability for unstructured data, the data you're storing in your file shares or exported file systems. But hey, guess what? Nutanix Unified Storage has that capability, and you're going to see it in action. Hey, I'm Steve from the Nutanix Technical Marketing team, and today, as part of our Unified Storage Disaster Recovery series, I'm going to do a little show and tell on Files Metro availability. We've actually had this capability for a while, but just recently, in version 5.2, we introduced Metro availability support for Nutanix Files running on AHV, which is, of course, the Nutanix hypervisor. Let me give you a quick explanation of how it works, some things to be aware of, and then we'll hop into a demo. Files Metro consists of two elements that work hand in hand: synchronous replication of the data and a witness mechanism that decides whether a failover should be invoked or not. Because the witness makes this decision rather than a human, failover is fully automated. You need three separate physical clusters for this to work. Your live file server is running on one of them. Let's call that the primary cluster. Another cluster, the recovery cluster, is receiving the replicated copy, and the file server will end up running here in a failover scenario. And the third cluster, which should be located at a different site to the other two, is home to Prism Central, which is where the all-important witness runs as an embedded service. Here's how it works in 30 seconds or so. The primary and recovery clusters frequently poll or heartbeat each other. If either cluster does not sense a heartbeat from the other, after a specified timeout period, it goes to the witness to try and acquire the witness lock, which is essentially the go-ahead to run the file server. The witness grants the lock to one of the clusters, making the decision in a safe way that avoids the dreaded split brain scenario. And just before we get to demoing, here are three fun facts. Fact number one. With this being synchronous replication, the round trip time between the primary and recovery clusters has to be less than 5 milliseconds. Fact number two, you need a stretched layer 2 network across the primary and recovery clusters. And fact number three, Files Metro has nothing to do with SmartDR, which replicates data at the share level asynchronously. With Files Metro, the entire file server gets replicated, and the remote replica is offline and inaccessible until a failover occurs, so only one side can be active at any given time. However, although Files Metro supports just a single recovery location, you can use SmartDR at the same time to replicate your data to a second destination, albeit asynchronously. Okay, let's see this in action. Starting off in the Prism Central dashboard, let's go to Files Management. We have a single file server deployed. Let's have a look at it. Not much going on right now, but that'll soon change. And let's see what shares there are. Note that we have both a Windows SMB share and an NFS export. We're going to focus on the NFS export for this demo, so let's check its mount path. And on the right hand side, you can see we have a Linux terminal session, and you can see the export is already mounted on this Linux client. Note that it's a hard mount, which means the client will keep trying to remount the export if it loses connectivity. Alright, now let's look at where our file server is running. That's the name of the physical cluster it's running on. Note that it ends in -3. And now let's have a look at our replication settings. Now we could create a new replication policy by selecting disaster recovery, then synchronous replication. But actually, we've already created a policy, so let's take a peek at that instead. Our policy is called Platinum. It consists of a number of properties. You get a summary of those here. And this view represents our data being copied synchronously from the production cluster to another physical cluster whose name ends in -4, and that's our recovery location. And in this next view, you specify the timeout value. That's the time the clusters will wait before trying to acquire the lock from the witness. 30 seconds is the default. And the network mapping between the source and destination clusters. It's really important again that you have a stretch layer to network across both clusters, because the file server will be brought up in its entirety on the recovery cluster with its existing network details. So if that same network does not exist on the recovery cluster, the file server will be incommunicado after failover. Okay, let's look at the monitoring view now. And again, you can see the replication relationship laid out clearly in this view. And we also have information about the last failover event. And there's a failover button. Now, this is only needed for planned failovers. If it's a genuine outage, the failover will be controlled by the witness in a fully automated fashion, and that's what I'm going to show you now. Okay, let's go back to our NFS client and start writing files to the file server. We have a script for that. Now, in the top terminal pane, you'll see each file write occurring, and the bottom is a monitoring script showing the share's availability plus all the files that it's currently storing. Now the fun begins. Let's take the cluster down. It's a single node cluster, so we can just power off the node. Don't try this at home, kids. All right, after writing data 11, the file share is now offline. We've got a timer built into the script so we can tell how long our client is without connectivity for. And at any time during the recovery process, you can check task progress in Prism Central. Now, I'm speeding things up here because I'm impatient, and I'm guessing you are too. And the failover is complete. Without any human intervention, the share, and indeed the entire file server, is available again, and the client writes continue, and of course, no data has been lost. Prism shows we're up and running in a failed over state. Thank you, Prism. And what was previously our primary cluster for running file services on is now our recovery location. And if we visit the event history, we can see the failover has been recorded there. Looking at the policy view, you can see in red that the source and destination files clusters are out of sync. Obviously the original primary cluster is offline, so let's power it back on again and see what happens. Let's hit the fast forward button. And just while the original cluster is powering up, let me show you that the file server is now running on -4 cluster, for the time being at least. And now our primary cluster is back up and running again, and we're syncing our file data back to it. And voila, we're now in a fully synchronized state. So at any point now we can fail back to our primary site. So let's go ahead and do that. This time it's going to be a planned failover. Failover is in progress. Let's hit the fast forward button one more time. And we're back where we started. Again, no data lost, and writes pick up from where they left off. The clusters are fully synced straight away, and we're back running on the -3 cluster again. And that's it. Once it's set up, you really don't have to do anything. And that's the beauty of it. Knowing your mission critical file data is automatically protected come what may. As always, thanks for watching, and don't forget to check out the other videos in our Nutanix Unified Storage Disaster Recovery series.